Hello, my fellow mathematician. Welcome to integration of algebraic substitution using U. This is calculus 2, which is done in a second here. I want to show you how you can integrate using U substitution, and we are going to go through about 15 examples, which is a quick revision for the student. So this we start with the first one here. Here you let whatever is in this bracket here to be U is equal to 3x minus 5. Then you differentiate both sides, du is equal to 3 dx. Then from here now, you obtain your dx, which will be given by du divided by 3. You divide by 3. Then you come here and substitute, so you are going to have a third integral of, in the stage of 3x minus 5, you will have u power 6 du. In the stage of dx, we have du, and this is a third there. This will give you 1 over 3 multiplied by 1 over 7 u power 7 plus c. By power rule, what you do here, you just add the index. You add the index and you divide by the result. This is equal to 3 times 7 is 21 u power 7 plus c. Hence, the integral of 3x minus 5 power 6 dx is equal to 1 over 21 bracket 3x minus 5 power 7 plus a constant c. So you simply substitute and simplify, and of course this is correct because when you differentiate, this will be 7 multiplied by 3, 27. We come to this other case here, this other part here, we deal with this. So even here we are going to let our u be equal to this part in the bracket here, which is x cubic minus 5. X cubic minus 5. So our du will give you 3x squared dx. You can divide both sides by 3 so that you get du divided by 3 is equal to x squared dx. X squared dx. Then you can see you have x squared dx. So you substitute. You write 1 over 3 outside the bracket. Then in the state of x squared dx, you are going to write du. Then you will have u du. You integrate. This is equal to that u squared multiplied by 1 over 2 plus c. Plus c. This will give you 1 over 6 u squared plus c. Meaning that integral of x squared into bracket x cubic minus 5 dx is equal to 1 over 6 into bracket x cubic minus 5 power 2 plus c. Of course, when you differentiate, you will have 2 here, then the 3x, and it will cancel. So you can see it is easier provided you master the art of substitution. Let us look at another example. Example 3 here, we let our u to be equal to 3t minus 2. You differentiate both signs, du is equal to 3 dt. You divide by 3 both sides to get du over 3 is equal to dt. Where you have 3t minus 2, you substitute with u. So you will have integral of 1 over 3 u power 8 du. Substituting there, this will give you 1 over 3 multiplied by 1 over 9 u power 9 plus c. Meaning that integral of 3t minus 2 power 8 dt is equal to 1 over 3 times 9 is 27 into bracket 3t minus 2 power 9 plus constant c. As simple as that. This other example here, you are going to let example 4 u to be equal to 8x. We shall let u to be equal to 8x plus 3, meaning that our du will be given by 8 dx. From here clearly, you can see that dx is equal to du over 8. Then you substitute integral of 1 over u du. Of course, you have 1 over 8 outside. This is equal to 1 over 8 natural logarithm of u plus constant c. Now, a student in calculus 1, I have showed you how you come up with this one. Also, in my previous presentation, I have discussed on how to integrate this kind of integrand. So you can check so that you get the knowledge. So it means that integral of 1 divided by 8 power x plus c plus 3 dx is the same as 1 over 8 natural logarithm of 8x plus 3 plus constant c plus a constant c, like that. So we look at another example which is a bit now different as compared to this. We have already considered the 4 of them. So welcome to this video tutorial. We are looking at integration by substitution of u. So this is an exponential integral. We are going to let our u to be equal to 2t minus 1. And we differentiate this both signs. Du is equal to 2 dt, differentiating this. Then we divide by 2 both signs. When you divide by 2, you will get 1 over 2 du is equal to d2. You come and substitute here. Half. This is half. Instead of dt, you write du there. Instead of 2t minus 1, you write exponential u. Now, we have found out in my previous studies on integration of exponential function. You can check in the link below that that one will be given by so you have 4 over 2 exponential u plus constant c. So you can check in my previous presentation, and you are going to see that the integral of exponential function is exponential function. I have shown you how we arrive at this so that you do not have to cram. So it means that our 4 exponential 2t minus 1 dt, when you integrate, This one will give you by 2 exponential 2t minus 1 plus constant c. That is the result. So remember to check in my YouTube channel so that you may know how come that the integral of exponential of any number is that exponential. Exponential u is exponential u. Now we look at this other case. When you look at this here, you have 2x, and in the index you have x squared minus 3. When you differentiate x squared, it will give you 2x, meaning that we can do it by simply using u substitution, whereby we are going to let our u be equal to x squared minus 3. You differentiate both sides to get du is equal to 2x dx. You can divide both sides by, so you can see that here we have 2x dx. So we are going to substitute 2x dx with du to get exponential u du, substituting 2x dx with du. This is equal to exponential u plus constant c, which is equal to exponential x squared minus 3 plus c. Hence, integral of 2x exponential x squared minus 3 dx is equal to exponential x squared minus 3 plus c. On how to integrate exponential function, you can check in my YouTube channel, whereby I've covered how to integrate exponential function through simple step method, and you are going to get the answer. How we arrive at this integral, you can check there in your stage of cramming so that you get the knowledge on how this is easily done. So we continue giving you more examples. Consider this case when you have power half. When you consider what is inside the bracket, you have 3x squared and you have x squared outside. So we can let our u to be equal to 3x cubic minus 2. Then you differentiate both sides to get du is equal to, when this is 9x squared, when you differentiate this part dx. Yeah, this is, you multiply by 3, you simply multiply by 3 and you reduce the power by 1. So 1 over 9 divided by 9 du is equal to x squared dx. We are going to substitute, so you have 1 over 9. Instead of 3x cubic minus 2, we will have u third power half. That way, instead of x squared dx, we shall have du. So we can do it here at this part. So you have 1 over 9 u power. This is half plus 1. So you have half plus 1. You can see this is 1 over 2 plus 2 over 2, which is 3 over 2. So you are going to have 3 power 3 over 2. You are supposed to divide by this. So divided by 3 over 2, which is equal to 1 over 9 times 2 over 3. Of course, plus constant c, remember that, which is equal to, that is u power 3 over 2 plus constant c. So this is equal to 2 over 27 u power 3 over 2 plus constant c. You simply add the index here. We have a half plus 1 will give you 3 over 2. Then you divide by the same. So you have 1 over 9 times when you divide by 3 over 2, you use the reciprocal, which is 2 over 3. So 1 times 2 is 2. 9 times 3 is 27. Meaning that now integral of bracket 3x cubic minus 2 power half x squared dx is equal to, the result is 2 over 27 into bracket. Our u is 3x cubic minus 2 power 3 over 2 plus constant c. That is what we obtain. As simple as that, student, it is simple to do, provided you understand the process. It becomes very simple to deal with it. So next we are going to consider the example now which involve denominator and the numerator. How do you integrate this, student? So you check the numerator is x squared, the denominator is 2x cubic, meaning that you can use the method of letting. You can let the denominator to be equal to u 2x cubic minus 3. Then you differentiate both signs to get du is equal to 6x squared, dx. Remember, on how to differentiate, you can check in my YouTube channel. I have covered all the differentiation and all the methods of differentiation. So we divide by 6 both sides, so you have 1 over 6 du is equal to x squared dx. So you can see the denominator is x squared dx. We will substitute with the du and we plug in 1 over 6. Then that is the numerator. The numerator is x squared dx. We are going to have 1 over 6 integral of, so here instead of x squared dx, we plug in du. Denominator 2x cubic minus 3 is u power 2. This can be written as 1 over 6. We take u power 2 up to become negative. Using this simple law of indices, that if you have 1 over a power n, this is the same as a power negative n when you take it up. So you integrating this, we will have 1 over 6. There is integral sign there, sorry, du. You add 1 and you divide by the result. So negative 1 plus 1 is negative 1. So you will have here divided by negative 1 u power negative 1 plus c. This will give you 1 over 6 divided by negative 1 is negative 1 over 6 u power negative 1 plus c. So integral of x squared dx divided by 2x cubic minus 3 power 3 dx is equal to negative 1 over 6 into bracket. Using this law of indices now, we can bring u power negative 1 down to make it positive. Our u is 2x cubic minus 3. That way, everything plus constant c. So that is how we differentiate the equation of this form. Next, we consider the following. How do you integrate the equation of this form? By use substitution. So you let your u to be equal to 3t minus 1. Then you differentiate both signs. Du will give you 3 dt. Next, you divide by 3 both sides to get du divided by 3 is equal to dt. From there now, you substitute. You have 2 over 3 sine of u du. These two I have taken it outside the integral sign and I have divided by this 3. Then, here you should be knowing the fact that when you integrate sine of u, you will get negative cos of u plus constant c. Plus a constant c. That is what you obtain when you integrate that. So, meaning that integral of 2 sine of 3t minus 1 dt, the result will be equal to negative 2 over 3 bracket cos of the small bracket 3t minus 1 plus constant c. So all what you need to do is just to you let the whatever is in the bracket to be u, then you differentiate both signs. After differentiating both signs, you divide both signs by 3, then you substitute. 2 can be taken outside the integral sign. Then when you integrate sine of u, you will get negative of cos of u. Then from there now, you substitute back the value of u and you get your result. This other one here is related. How do you integrate 4 cos of bracket 6x minus 3? So you do it by letting. So you are going to let our u to be equal to 6x minus 3. Meaning that du is equal to 6 dx. When you differentiate both signs, you divide by 3 both signs to get du over 3 is equal to dx. You substitute back there, and as you substitute, you remove 4 outside. So you will have 4. This is 6, sorry. 4 over 6. Taking this 6 outside the integral sign, integral of cos of u du. Our u is 6x minus 3. Our dx is du that way. This is equal to 4 over 6 sine of u plus constant c plus constant c. So 4 by 6, you can write it as 2 over 3 sine of our u is 6x minus 3 plus c. Hence, when you integrate 4, integrating 4 cos of 6x minus 3 with respect to dx, the result will be 2 over 3 sine of 6x minus 3 plus constant c. That is what you do when you make this substitution. You can see it is simple, provided you follow the procedure. So you let whatever is in the bracket to be u, differentiate both signs, divide by 6, you plug in, you take in 4 outside the integral sign. Integral of cos u is sine of u by 2, 2 by 2, 3. Then you substitute back the value of u, which is 6x minus 3, to obtain your result as shown there in those simple step method. We look at another example. Here you have integral of x squared turned into bracket x cubic plus 3 dx. So how do you integrate this? You let your u to be equal to x cubic plus 3. Then you differentiate both sides to get du is equal to 3x squared dx. From there, you divide both sides by 3 to get 1 over 3 du is equal to x squared dx. Then you substitute back here. You have x squared dx as your du. So you take advant outside, advant integral of tan of u du. Tan of u du. Now, from my previous presentation, I have shown you how you obtain the integral of tan of u du. So here I will just give you the result. So this is the same as 1 over 3 sec of u plus constant c, plus a constant c, which is equal to a third sec of, this is modulus, our u was x cubic plus 3 modulus plus c plus c. This is natural logarithm, sorry, there is ln, natural logarithm of that, natural logarithm of sec. Yeah. So integral of tan of u is natural logarithm of sec of u. So when you substitute back, it will be a natural logarithm of sec of u. Hence, when you're integrating, so the integral of this will give you as a third natural logarithm of sec of x squared, x cubic, sorry, this one, plus 3 plus constant c. On how to integrate tan of u, I have done the study. You can check the result. This one can also be written as negative a third cos of x cubic plus 3 plus c. It will give you the same result. We have this other example here. Here, first of all, we are going to write it in terms of cot. This is the same as cot of t plus 2 dt. 1 over tan is the same as cot. So we let our u to be equal to t plus 2. You differentiate both sides to get du is equal to dt. So you plug back where you have t plus 2, you write u du. Now, also on how to integrate cot of u, I have already done the study. You can check in my YouTube channel at Luke Aaron 1. I will also provide the link below so that you can see how we integrate cos of u. So when you integrate cos of u, the result will be natural logarithm of sine of u plus constant c. So meaning that integral of 1 over tan of t plus 2 dt is equal to natural logarithm of sine of u plus c, which is equal to natural logarithm of sine of t plus 2. That is the value which you obtain after integrating. Let us also look at this example in our presentation and see how we can do it. So we are going to use the fact that 1 over sine is equal to 1 over is the same as cosine. So we are going to have instead of sine we will have cosine into bracket t power 4 plus 5. T power 4 plus 5 multiplied by 4 t cubic d this is dt, sorry, dt. So you can see here we have 4 t power cubic, here we have t power 4. So meaning that we can let our u to be equal to t power 4 plus 5. Then we differentiate both the signs. Du will give you 4t cubic dt. Clearly you can see here you have 4t cubic dt. So all this will be substituted with du. Where you have t power 4 plus 5 will be substituted with u. So we can write as cosec of u du. This is equivalent to, natural logarithm of cosec u minus cot of u plus c. Again, on how to integrate cosec of u du, you can check in the link which I will provide, and also or you check it through my YouTube channel at Luke Aaron1, and you are going to see how you obtain the integral of cosec of u. But the result is this one. So it means now this one we can substitute natural logarithm of cosec u. Our u is t power 4 plus 5 minus cot of t power 4 plus 5 modulus plus constant c. Hence now our integral here will give us natural logarithm modulus of cosec of t power 4 plus 5 minus cot of t power 4, sorry, plus 5 modulus plus constant c. This can be simplified, but even if you leave it at that level, it's okay. Look at how we can integrate 5 t power 4 divided by cos into bracket t power 5 minus 4 dt. Now we use this fact that 1 over cos t is the same as sec t. So everything here we are going to write it in terms of sec. So in terms of instead of 1 over cos, we can write it as sec bracket t power 5 minus 4 multiplied by 5 power t power 4 dt. We let our u to be equal to t power 5 minus 4. Then we differentiate both signs. Du will give you 5t power 4 dt. At this level now, you can see here, you have 5t power 4 dt. So where you have 5t power 4 dt, you substitute. So sec of u du. Here, I have substituted 5t power 4 dt with du and 5t power 5 minus 4 with u. So integral of sec of u is natural logarithm of sec of u plus tan of u plus constant c. Now, on how to arrive with this one, I have already done it in my YouTube channel. I request you to check at Luke Aaron 1. When you go to my YouTube channel, when you go to YouTube app and you type the word Luke Aaron 1, you are going to see how I have done the integration of this part here. You can also check the link which I will provide below to see how we arrive at this value. So we can substitute natural logarithm of sec of, instead of u, we write t power 5 minus 4 plus tan of t power 5 minus 4 modulus plus constant c. Hence, integral of 5t power 4 divided by cos of t power 5 minus 4 dt will be given by natural logarithm of sec of t power 5 minus 4 plus tan of t power 5 minus 4 modulus plus constant c. This can be simplified further, although even if you leave at that level, it's okay. We look at this other example here. You have 2t dt divided by sine squared of t. This is not sine squared, sorry, divided by, divided by sine squared. It's okay, because I want divided by sine squared bracket t squared plus 3. So we are going to use the fact that this can be written as, instead of sine, we can write it as cosec squared into bracket t squared plus 3 multiplied by 2t dt. So 1 over sine is the same as cosec. Now, because sine is squared, we'll write it as cosec squared. So when you compare this part here, t squared plus 3 and 2t, this is the derivative of t squared. So we can let our u be equal to t squared plus 3, meaning that our du is equal to 2t dt. 2t dt. Then we divide by 2. By 2, both the signs, du is equal to t dt. Or you can even leave it at that level. So you can see here we have 2t dt, which is equivalent to du. So we substitute here cosec squared of u du. Substituting where you have 2t dt with du, and our t squared plus 3 with u. This will give you a negative cot of u plus constant c. Now, on how to integrate cosec squared, you can check in my YouTube channel. and you are going to see the result. I have done it on my YouTube channel, so you can check on the link below so that you know how to get the integral of cos x squared. I have provided it in the link below. This is equal to negative cot of, instead of u, we substitute it back with t squared plus 3 plus constant c. Hence, the integral of this nature, the result will be equal to negative cot of bracket t squared plus 3 plus constant c. That is the result. Remember, as I mentioned to you, that on how to integrate cos x squared, you can check in my YouTube channel so that you may know how it is done. There is this other interesting part here. Here we are going to use the fact that 1 over cos is the same as sec. So we can write this as integral of. So this part here can be written as. So the first step, we are going to rewrite 1 over cos squared as sec squared, because 1 over cos is the same as sec. So this is sec squared into bracket t cubic plus 5 3t squared. So when you look at whatever is here, t cubic is the same as differential of 3t dt. So we are going to let our u to be equal to t cubic plus 5, meaning that our du is the same as 3t squared dt. So integral of sec squared of u, instead of t cubic plus 5, we are going to write u. Instead of 3t squared dt, we shall write du. Now, again, in my YouTube channel, I have shown you how to integrate sec squared u, and the result is tan of u plus constant c. You can check in my YouTube channel at Look Aaron 1, and you are going to see how do you integrate sec squared u so that you don't need to cram. Kindly check so that you may learn together. So we can substitute the value of u back. Tan, the u was t power 3 plus 5 plus constant c. Hence, the integral of 3t squared dt divided by cos squared into bracket t cubic plus 5, the result is what we have found here. The result is tan of t cubic plus 5 then plus constant c. So that is how you obtain that result easily using the method of substitution. Let us see as to how we can integrate this integral here, sec into bracket x cubic plus x squared into bracket tan into bracket x cubic plus x squared multiplied by 3x squared plus 2x dx. Now, first of all, we let our u to be equal to x cubic plus x squared. Then we differentiate both signs to get du is equal to 3x squared plus 2x into bracket dx. So what we are going to do, you can see our du is the same as this part here. So integral of sec of u multiplied by tan of u du. Our u is x cubic plus x squared that way. Our 3x squared plus 2x dx is du. This is the same as sec of u plus constant c. You can check in my YouTube channel on how to integrate sec of u, tan of u, or you look at the integrals tables of trigonometric function. Meaning that now integral of sec of bracket x cubic plus x squared multiplied by tan of bracket x cubic plus x squared multiplied by 3x squared plus 2x dx. The result is very simple, sec of x cubic plus x squared plus constant c. Provided you know what is the integral of sec of u, tan of u, and that one you can easily find it in the integral tables, or you check in my YouTube channel. I have done it, and you are going to get your result. So another example, you integrate. This is example 17. In this consideration, you integrate cosec. You integrate cosec of x power 4 minus x cubic multiplied by cot of x power 4 minus x cubic, everything into bracket, 4x cubic minus 3x squared into bracket dx. It appears to be scary, but it is simple. So first of all, you start by letting your u to be equal to x power 4 minus x power 3. Then you differentiate both signs to get your du as equal to, when you differentiate x squared, it will give you 4x cubic minus x cubic differentiated is 3x squared. This is your dx. You can clearly see that this part here, all of it is equivalent to du. Then you have integral of cosec of u multiplied by cot of u du. All this part here is 4x cubic minus 3x squared is dx is du. Now again, from the tables of integrals, the integral of cosec u, cot u will give you negative cosec of u plus constant c, or you check in my YouTube channel on how you arrive to that. This is equal to negative cosec of x power 4, plugging back the value of u, minus x power 3 plus constant c. Hence integral of cosec of x power 4 minus x power 3 cot of x power 4 minus x power 3 multiplied by 4x cubic minus 3x squared dx. The result will be negative of cosec x power 4 minus x power 3 plus constant c. So that is how you obtain the result easily. That is now the beauty in substituting, provided you know the procedure. It is very simple, and you know the integral of cosec of u, cot of u. It becomes easier to obtain your result. We look at how we integrate this. So in this first case here, we are going to let our u to be equal to cos of x, our du will be equal to negative sine of x dx. So we substitute negative integral of u squared multiplied by du, which is equal to negative 1 over 3 u power 3 plus constant c, meaning that integral of cos squared of x multiplied by sine of x dx will give you negative than cos cubic of x plus constant c. So you just let your u to be, when the power of cos is even and that of sine is odd, the rule is you let your u to be that of the power which is even. Then after differentiating, you get sine x dx is equal to that. You can then you substitute. Then by power rule, you add 1, which is power 3, and you divide by the result, which is that one. Then from there now you substitute back the value of u. This other one, it is related. So here we are going to let our u to be equal to sine of x. Then you differentiate in both signs. When you differentiate the sign, it will give you cos of x dx. Then you substitute. Where you have sine, you write u and u square. Instead of cos x dx, you write du, which is equal to, by power rule, you add 1 and you divide by the result. So 2 plus 1 is 3. You divide by that, u power 3 plus constant c. So it is simple, as you can see, student. So this will be 1 over 3. Our u is sine cubic of x plus constant c, meaning that integral of sine squared x cos of x dx is given by a third sine cubic of x plus constant c. That is how you obtain this result easily in this simple steps method, provided you know the differentiation. Of course, calculus 2 requires you to have the prior knowledge of calculus 1. Hello, my fellow mathematician. Welcome to calculus 2. We are continuing to see how we can integrate this type of function by substitution. So here we are going to let, when you look at this power and this one, this is the derivative of this. So we are going to let our u to be equal to sine cubic of x. Then we are going to differentiate both signs by chain rule. So here we are going to have 3 sine of x. We reduce this by 1. So to get sine squared, then we integrate the other part, which will give you cos of x dx. Now when you look at this part, you have sine squared dx cos x, sine squared x cos x dx. Of course, so we are going to have a than exponential u du. Now, sine squared dx cos x dx, it is du. We are dividing by 3 because of this 3 here. Then sine cubic x is u, which is equal to a third of exponential u plus c, which is equal to a third exponential of sine cubic x plus constant c. It is that simple. To integrate this is very simple. All what you have to do it is to realize, to recognize that sine square dx cos x dx, it is the derivative of sine cubic x. Once you realize that, you let your u to be sine cubic x, then you get your du as that, then you substitute here to obtain your result. As simple as that. Also, you are going to integrate a that cos squared x multiplied by sine of x, then exponential of cos cubic x dx. When you look at this, cos cubic x is the derivative of 3 cos squared x multiplied by sine x. So here you simply let your u be equal to cos cubic x. Now, on how to use chain rule, you can look at my YouTube channel. I have done it on the on differentiating trigonometric function using chain rule. You are going to see. So this will give us du will give us negative 3 sine of negative 3 cos of x squared. By chain rule, you drop 3 in front, you reduce the index by 1, so this will be cos squared x, then you differentiate this. Sine cos differentiated will give you sine x. Of course, negative, that is why I've written negative there. So clearly you can see here, you have 3 cos squared x sine x dx. Here, you have negative 3 cos squared x sine x, there is dx here, dx. Then we substitute. So negative, because of this negative here, exponential u du. Our du is 3 cos squared dx sine squared dx dx. When you integrate this, it will give you negative exponential u, negative exponential u, negative exponential u plus constant c, which is equal to negative exponential of cos cubic of x plus constant c. So that is the integral, as simple as that. Also, you are to integrate, this is 21 of our consideration, 22. You are to integrate sec of x, tan of x, exponential sec of x dx. Now here, you just recognize that when you differentiate sec x, the result will be sec x tan x. So simply you are going to let your u be equal to sec of x, then you differentiate both signs with respect to du, which will give you sec of x tan of x dx. Here we substitute exponential u du. Our sec x tan x, everything is du. when you integrate exponential power u, it will give you exponential power u plus constant c, which is equal to exponential power of sec of x plus constant c. As simple as that. So thanks so much, my fellow mathematician, for taking your time to study with me the methods of differentiating integrals using U substitution. We have considered all possible cases which you may encounter. Remember to like, to subscribe to the channel, also to share with the other mathematicians, and also you can leave a comment so that we may know other areas which you would want us to consider. Thanks so much. See you in the next video which I upload every day.